Hello everyone, in this video we shall learn about the coordination compounds. I'll just give introduction and the basic terms related to coordination compounds. Now I'll just discuss introduction. There are three types of inorganic salts. They are simple salts, double salts, coordination compounds are also called as complex salts. First of all, what is simple salts? What are simple salts? These compounds are made up of one acid and one basic radical. That is, these compounds are made up of one acid and one basic radical. Examples are common salt, that is NaCl. In NaCl has a positive charge, Cl has a negative charge. These compounds are made up of one acid and one basic radical. Here basic radical is Na plus and acid radical is Cl minus. So simple salts are the combination of one acid and one basic radical. The other example is sodium nitrate. Na plus NO3 minus. And the second one is double salts. These compounds are made up of two simple salts. Example is more salt. It is also called as ferrous ammonium sulfate, that is FeSO4 NH4 twice SO4 6H2O. As I said that double salts, these compounds are made up of two simple salts. Here see FeSO4 and NH4 twice SO4. It is a simple salt. It consists of one acid radical and one basic radical. And here also you can see there is another simple salt consisting of one acid radical and one basic radical. The combination of two simple salts is called as a double salt. The common example is more salt. It is also called as ferrous ammonium sulfate. And the point is, they are stable only in solid state. They broke they are broken into their individual compounds when they are dissolve in water. The third type of inorganic salt is coordination compounds or complex salts. These are the compounds in which the central metal ion is surrounded by certain number of ions or molecules through the coordination bonds. That is, example is cupramonium sulfate. That is CuNH3 4 S44. It is cupramonium sulfate. It is the example for coordination compounds or complex salts. These are the compounds in which the central metal ion is surrounded by certain number of ions or molecules through the coordination bonds. It is a central metal atom. It is surrounded by certain number of ions or molecules, that is NH3SO4 like this. They are bonded through coordination bonds. Before studying what are coordination bonds, I will just explain what are ionic bonds and covalent bonds. Ionic bond is the electrostatic force of attraction between the oppositely charged ions resulting in the formation of an ionic molecule. Let us consider the formation of a NaCl here. Consider the electronic configuration of Na, 1s2, 2s2, 2p6 and 3s1. And when it gives its one electron to the Cl, it becomes 1s2, 2s2, 2p6. Here 3s1 is missing. So it gains a positive charge. When it gives its one electron to the Cl, its valence electron to the Cl, it becomes 1s2, 2s2, 2p6 and it gains a positive charge. Here consider in the Cl, it has an electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p5. When it gains one electron from the Na, it becomes 1s2, 2s2, 2p6, 3s2, 3p6. So it gains a negative charge. So here the formation of Na plus Cl, Na gets positive and Cl gets minus charge. Ionic bond is the electrostatic force of attraction between the oppositely charged ions resulting in the formation of ionic molecule. It is the ionic molecule. Now we can study about covalent bond. Covalent bond is formed by the mutual sharing of electrons from both the participating atoms. The mutual sharing of electrons is done. Now let us consider the example of a chlorine atoms for the formation of chlorine molecule of chlorine. Here chlorine consists of 7 electrons in their valency shell, and this chlorine also contains 7 electrons in their valency shell. When these combine, they combine to form a stable octet structure in their valency shell. To form a stable octet structure, it needs 8 electrons. Here we can see it has 7 electrons, 1, 2, 3, 4, 5, 6, 7. So it needs another electron. It will take it here, and we can see here 1, 2, 3, 4, 5, 6, 7. It will combine here to form a 8 electrons. Now it has gained its octet structure. See 1, 2, 3, 4, 5, 6, 7, 8 and 1, 2, 3, 4, 5, 6, 7, 8. It is a mutual sharing of electrons between both the participating atoms. Here the participating atoms are Cl and Cl. Here to form one covalent bond, here is one covalent bond. It should share one electron each. Both these two should share one electron each. That is, covalent bond is formed by the mutual sharing of electrons from both the participating atoms. They combine to form a stable octet structure in their valence shell. Two chlorine atoms also form one covalent bond to give one molecule of chlorine. This is about the covalent bond. Here the mutual sharing of electrons is done. I already said that in the coordination compounds there is a coordination bond. Now we shall study what is coordination bond. It is a special type of covalent bond that it is formed by sharing of electron pairs from single atom. Both shared electron or donated by the same atom. Here I will just give the example and I will explain. Formation of ammonia boron trifluoride. See, ammonia plus BF3, it forms ammonia boron trifluoride. It is coordinate bond. Here the nitrogen atom in an ammonium molecule donates one pair of electron to the vacant orbital of the boron atom. See here, nitrogen atom in an ammonium molecule donates one pair of electron to the vacant orbital of boron atom. It is vacant, it is electron deficient. Here nitrogen donates one pair of electrons. It has pair of electron. It will donate to the boron atom and here become nitrogen atom is donor, boron is acceptor. See here the definition. It is a special type of covalent bond that is formed by sharing of electron pairs from single atom. Both shared electrons are donated by the same atom. See here the shared pair of electrons on the nitrogen is shared to the boron and nothing has come from the boron, only nitrogen is sharing here. So it is the coordination bond. It is the coordination bond. For a coordination bond, you should represent this symbol. Here the shared pair of electrons are transferred to the boron and boron does not transfer any of the electrons to the nitrogen. It is about the coordination bond. I have already said the definition of coordination compounds. These are the compounds in which the central metal ion is surrounded by certain number of ions or molecules through coordination bonds. Here the ions or molecules are connected to the central metal atom through coordination bonds. That is, central metal atom are surrounded by ligands. Ligand will be bonded by the coordination bonds to the central metal atom. I will explain it later. Now here we can see what are the differences between the double salts and coordination compounds. We already know the definitions. I'll just say the differences. It loses its identity in solution, but the coordination compounds retains its identity in solution, and here in the double salt it does not contain coordinate bonds, but it contains coordinate bonds. Here it is stable in solid state. It is stable in solid and solution state. It has only primary valences it shows both primary and secondary valences. Now in the double salt, it loses its identity in solution, but in the coordination compounds, they retain their identity in the solution. Here it does not contain coordinate bonds in the double salts, but in the coordination compounds it must contain coordination bonds. Now it is stable in solid state. Double salts are stable in solid state, but in the coordination compounds they are stable in solid and solution state. Double salts as only primary valences. Coordination compounds shows both primary and secondary valences. I will discuss about primary and secondary valences in the next video. Thank you. Please subscribe to our channel.